about some of the new webinars that we're going to be doing. We're excited to be piloting some faith, health, and the environment webinars. We're piloting a program in partnership with North Carolina State University Citizen Science Hub, as well as also a citizen science internship program at Shaw University. And the pilot and initiative is intended to help faith communities look at the environment with eyes of wonder, to have both a science and a faith perspective on the world around us and what it looks like, to incorporate, ordinary things that we use in our religious rituals, and to look at those kind of in our sacred conversations through a faith framework. And then to have connecting webinars like this one today, that's called the Faith and Health Connection, where we have experts, Haley Smith and Nicole Esch are here with us this morning, and they will bring the science framework and perspective around those things, while also still connecting it to like everyday life and what we can do as people of faith to be not just good caretakers of creation, but to situate ourselves within the environment that we live, and not just see ourselves as a part, but as a part of a part as in like APART, and see ourselves as two separate words, a part of the whole. And so thank you all for joining us. We had a number of people registered, and some people don't always attend because we send out the recordings. So even if they're just a low number of participants, we will be recording the session anyways. And we're very excited to be doing this. I think there's a couple more pieces of information we might share about the Environment, Faith, and Health Initiative, like some of the other things that'll be coming up and what some of the benefits for faith communities will be. So without further ado, I'll introduce Haley Smith and Nicole Esch, who will be doing our presentation today on the science of water. And thank you both.
Thanks so much, Nicole, and thank you for having us today. I'm going to attempt to share my screen. As I mentioned, I'm horrible at technology, so everyone bear with me just a minute if you don't mind. Well, that is my screen, but that's not the part of my screen I wanted you to see. Hold on. I'm truly, truly horrible at technology.
I mean, so far it's going okay.
It's true. I mean, I got halfway there, right? This is what I wanted to do the whole time. There's no like really good way to do presenter view when you're on Zoom, so you have to kind of get fancy with it. We're almost there, y'all. I'm so sorry. All right, so you should be able to see at least part of my slide now. And now you should be able to see most of it. Okay, great. I'm gonna attempt to make this interactive, but I know we do have a small group. So if those of you that are here don't feel comfortable unmuting or participating, that's okay. Nicole, Jay, and Elizabeth, I welcome you to be participating too. And if anybody, has questions, please feel free to unmute yourself and ask, or drop them in the chat at any time. And then we are also going to try to definitely make sure to have some time for Q&A at the end, especially to talk about the partnership program that Nicole was mentioning, and yeah, give you guys a chance to ask any questions you may have about next steps. So yeah, with no further ado, we'll go ahead and get started. So as Nicole said, we're talking about the science of water today, but we are going to kind of try to ground that in water's role in everyday life and in our world. Obviously, you can see our names here, but the two of us presenting today are myself, Haley Smith, and I'm a graduate student at NC State University in the Department of Forestry and Environmental Resources. And I'm joined today by Nicole Esch, who's the program manager, project coordinator, something like that for Crowd the Tap. Nicole, do you want to say anything else in introduction of yourself?
I mean, that was pretty much it. I also graduated from UNC, as you can see in the picture there, and then my master's was at NC State as well. So we are both NC State affiliated.
Perfect. Thanks, Nicole. Great. So just a little bit about where we're going today and what we're going to be talking about. Like I said, we're going to kind of start off with just thinking about the importance of water in our lives, and especially focusing on water resources that we have available to us in North Carolina. We're going to transition into talking a little bit about what it means for water to be clean and safe for us to use and be in and around. And then we're going to kind of hand it over to Nicole, and she is going to talk a little more about where our water comes from, what happens to it before it gets to us. And then we're going to kind of round it off by talking especially about Crowd the Tap, which is the program she helps us run here, and then how you can get involved with Crowd the Tap and other activities through this mini grant opportunity. So like I said, feel free to let me know any questions at any point. Of course, my dog is getting excited and wants to be involved now that I'm talking. So my hope here was that you guys could kind of tell me where everyone's joining in from today. I don't know if anyone has used the annotate feature before on Zoom, and if that is too difficult to figure out, maybe you can just tell me in the chat where you are and I can annotate where everyone is for us to visualize. But if you know how to use the annotate feature on Zoom and you want to put like a star or a check mark or something and let us know where you are. So Elizabeth, is that Durham?
I was trying to go for Durham. Yeah.
Okay, cool. Yeah, honestly, I didn't obviously put all the cities on here, but that was my best guess.
And Steven says he's from Greensboro.
Okay, great. So let's see. I can put a check mark there in Greensboro. I'm also in Raleigh. My dog is in Raleigh. Okay, great. So most of us are kind of here in the central part of the state in the Piedmont. So I guess probably have kind of similar geography.
Winston-Salem.
Winston-Salem. Okay, let's see. Cool. So you're the furthest west and north up there in Winston. But yeah, so let's see. Looks like, and I will get back to this map a little more later on in the presentation, but this map is a surface water map of rivers, lakes, and streams in North Carolina. And then it also shows the colored boundaries are different river basins throughout the state. So we're actually representing several different river basins here today. So that's kind of fun, even though we're not too far away. All of our water is kind of connected in different ways, and we're fed by different water resources. So kind of fun to think about. All right, one more question. Oh, let's see if I can clear the annotation. There we go. One more question before I really start going in deeper here. If you don't mind also jaffing the chat or unmuting, if you guys could maybe just share some ways you can think of that you engage with water, use water, see water in your everyday lives.
I'm currently drinking coffee and I used water to make coffee.
Coffee is an important one.
Taking a shower, watering plants, washing dishes.
Yeah, lots of everyday activities.
Yeah, washing anything.
Washing anything, that's true.
Recreation, I think of recreation. When it's warm enough, go outside and go to a river and swim or something.
Hopefully soon, right? Maybe in the next month or so. Great. Well, yeah, all of you really touched on a lot of the main things I was going to start off. Oh, and someone said in the chat, yeah, drinking, watering plants, dishes, cars, fishing. Oh, fun. You go fishing with your grandsons. That's awesome. Great. Well, yeah, you guys really touched on a lot of the main ones. So I think when we initially think of water, a lot of us do kind of think of these typical everyday uses of, consumption, watering plants, cooking, cleaning. You mentioned cars there, Stephen. So yeah, cleaning our cars, brushing our teeth, showering. And yeah, like nourishment, hygiene, cleaning are really some classic everyday uses for water.
Sitting next to water, like,
yeah,
I don't know. So there's something about the sound of water that I find really soothing.
Oh, I agree.
So
Just
just
like,
sitting
hearing it like
next
lap
to
against
water.
the edge of the pond
Yeah.
or lake. Yeah, absolutely. Totally. And actually, I do have a slide on recreation too here in a second. So you guys beat me to the punch. But yeah, so, you know, I think a lot of us do use water so much in our everyday life. Oh, and I am covering up that. I see, can't do technology. But, you know, we may not think about how much we use or like what life might be like if it wasn't available. And so just looking at, hold on, y'all, I'm gonna adjust my screen again really quick. I'm so sorry. There it goes. So just thinking about, you know, how much water we might use. In North Carolina, these last stats I was able to find were from 2015, but for domestic public and wastewater treatment, every day in North Carolina, people use enough water to fill up 9 of the Great Pyramid. And if you don't know how big the Great Pyramid is, because I wouldn't have without this, but it is about half the height of the Eiffel Tower. It is almost twice the height of the Statue of Liberty or Big Ben. So that's a lot of water on a daily basis. And I will again get to this later, but you know, we are really fortunate in North Carolina to generally have access to a lot of amazing water resources. And so we don't necessarily always have to think about scarcity and, you know, how much water we have access to. But just to kind of put things in perspective about how much water we really are talking about here to fuel everyone's lives. So yeah, getting into some other uses, like everyone said, recreation. I also really like to get outside. I haven't gone fishing for a long time, but I do have some really lovely memories of going fishing with my grandfather as a child. And I love getting out and paddling, more flat water paddling, like canoeing on a lake, things like that. And yeah, like Nicole Johnson said, I just love to just sit by and watch the water go by. And I think we might get into this a little more in some of our future webinars, but you know, I think there just are so many benefits for people to getting outside in nature. Water especially can be so peaceful, but a lot of like physical and mental health benefits to outdoor recreation. But water-based recreation in particular, so boating and fishing, is actually the biggest outdoor recreation industry category in North Carolina. So not only people get out and really take advantage of this and enjoy it a lot, but it also can play a big part in our economy as well. So moving on to some areas that I don't think I actually heard anybody mention, there are a lot of ways that water impacts us every day that, you know, maybe we don't think about so often. And I know I certainly don't think about these necessarily on an everyday basis, but actually a ton of water goes into kind of more indirect uses, things like agriculture, and that includes both livestock and irrigation, even aquaculture for, you know, fish industry. So, you know, using it for manufacturing, cooling, things like that. And then a huge proportion of water usage in North Carolina goes to power generation, particularly thermoelectric. So these steam towers that you might have seen around. I can think of at least 2 places in North Carolina, like near Lake Norman and south of Asheville, that I've seen these driving down the road. But if you've ever seen these big steam columns, those are generally used for cooling, for creating thermoelectric power. And then obviously water can also be used for electricity generation itself. So hydroelectric power, especially in North Carolina, kind of in the western part of the state where we have more of that kind of dramatic topography, is where we see more of that in the state. But yeah, all kinds of other indirect ways that water is impacting our lives, creating the food we eat, the items we use, the clothes we wear, and you know, even our ability to turn on a light. And then, just because I like to put numbers on things,
I was about to ask.
Yeah. So to put this a little more in perspective again, whereas, you know, for public wastewater and domestic use, we had 9 pyramids, all of these industries together. And this does not include hydropower, because hydropower isn't so, there's not really a lot of like byproducts for hydropower. It just kind of runs through and keeps going. But for thermoelectric industry and agriculture. In one day in North Carolina, we're using 36 billion gallons of water for these industries, which is equivalent to 56 of the Great Pyramid. So quite a bit of water, and a large proportion of that is for power, like I mentioned. All right, so kind of again,
42 billion, 6 billion for domestic use, another 36 for industrial, and
per day. It's a lot of water. So again, fortunately, we do have an abundance of wonderful water resources here in North Carolina. So again, getting back to this map, this was surface water in North Carolina. So you can see basically all of the major streams, lakes, and rivers, and then the different river basins. And I think since neither of our guests here today were here last week, I think it would be nice to reiterate something Nicole S. shared last week, which is, I think it's important to remember that these, this map is displaying this as if these boundaries end where North Carolina ends, but our water is connected to the water in all of the states all around us, and these arbitrary state lines we draw, the rivers don't pay attention to that. So our water impacts and is impacted by things that go on in the states around us as well, and even in our neighboring river basins here in North Carolina. So specifically focusing on surface water, which is what we could see there, I think, so surface water is exactly what it sounds like. It's water that's on the surface of the earth. It's what we can see and interact with a little bit more easily. And so I think it gets a lot of focus because we can see it better. And we do tend to use more surface water than groundwater. It's easier to access. It's easier to channel into pipes and things like that. But a lot of people do get their water from groundwater, and industry and agriculture and others use wells and other sources of groundwater for different activities. So both are used, but a lot of our emphasis ends up being on surface water. So just taking a quick look at what our surface water resources are here in North Carolina, we have over 37,000 miles of rivers, which is enough to wrap around the earth 1.5 times approximately. So that's a lot of rivers. And then lakes. So lakes are a little tricky because obviously their size can vary throughout the year with evaporation and different seasons and stuff like that. But on average, we have about 350,000 acres of lakes in North Carolina, which is about 1/3 the size of Rhode Island, if that tells you much. It sounds small, but still a pretty large surface area. And then wetlands, which I think are maybe one that they're not as easy to like go paddle in or fish in, so maybe they get left out a lot, but they actually account for a whole lot of our surface water and have a lot of other important qualities to them when it comes to water quality. And so there are 5.7 million acres of wetlands in North Carolina, which accounts for 17% of the state land cover. And most of those are situated in the eastern part of the state. So kind of starting to be a little more common right around where all of us are, kind of in eastern central North Carolina, but just really common along the coast. And we care about wetlands because, they are important habitat for a lot of wildlife. They can be fun to recreate in. You can paddle in some wetlands. They produce a lot of food. But then they also have a lot of important properties when it comes to the quality and availability of water as well. So they retain a lot of water. They actually hold a lot of water, so they can help to maintain water and resupply our groundwater supply. So they help with availability and quantity of water, as well as they have really important filtration properties where they slow down water and help filter out sediment. And so they also help with clean water. So yeah, I think wetlands get neglected a little bit sometimes when we think about our water resources, but they have a lot of really important properties. I'm gonna try to make this really fun and quick, but I felt like I would be remiss to do a science of water presentation and not talk a little bit about the actual science of water. So if you, like me, didn't remember everything from your high school chemistry class, kind of reaching back just a little bit, we probably all know water is H2O, right? What does that mean? And what does that actually tell us about what water can do and you know, how it interacts in the world? So it's got 2 hydrogens and 1 oxygen. And the way those atoms interact and create this molecule makes it a polar molecule. So it actually has kind of like partial positive and negative charges on different parts of the molecule. And that has a lot to do with how water functions in the world and interacts with other materials. And yeah, it gives it a lot of these special properties that make water so important to life on Earth. And so for one thing, those partial charges help it dissolve a lot of other things. So things like salts, things like, I don't know, I'm mostly thinking salts, but lots of ionic properties. And so that can make water really important for being able to carry nutrients, a lot of which we can get in our bodies through drinking water. It also has high heat capacity, which if you have ever visited the ocean or lived near the ocean or even a large lake, you've probably appreciated this property of water where it tends to cool and heat much more slowly than the surrounding air temperatures. So, you know, if you go to the beach in the summer, it actually tends to be a bit cooler than inland 20 miles might be. Or if you go in the winter, it tends to be warmer. So it really helps regulate air temperatures. It has a high heat of vaporization, which is a fancy way of saying it can take in a lot of heat before it evaporates. So this is why things like sweating help cool us off, because that sweat is not only cooling you off as it evaporates, but it's also pulling out a lot of heat from your body on the surface of your skin, and then helping that go off into the ether. I don't know. But that can also be called evaporative cooling, is another fancy word for that. Cohesion and adhesion, which is a fancy way of saying water sticks to itself and sticks to other things. And again, that comes particularly from its like charge, its polar qualities. And this particularly makes water have its property of surface tension, which is part of how it has that really nice little, I don't know if you guys can see my mouse there, but how it has that really nice little droplet form, because it kind of sticks to itself and sticks to the surface of that leaf there. But that surface tension helps us float on water. You know, it helps with a lot of different ways that things interact with water. And then it's solid versus liquid density. So basically, unlike most materials in the world, solid water, aka ice, is actually less dense than its liquid, which is somewhat unusual, quite unusual, in fact. And so ice floats. And then out in the world, that really impacts things like, you know, it helps to insulate things like lakes and ponds, and actually helps keep the water underneath not frozen during the winter, and insulates from the cold. So a lot of the little critters that live in water can actually survive the winter. So yeah, hopefully that was a quick refresher of some of your high school chemistry and some of the funky and unique properties of water that help it do some of the things we need it to do to survive. Okay, I'm going to pause before I move to this next one because I feel like it gets dramatic really quick and I don't want to go to an immediate downer. But thinking about, again, some of these properties of water, especially its ability to dissolve and carry nutrients, to retain heat or, you know, absorb heat, things like that. This also can sometimes mean that water has a tendency to retain not so good particles and nutrient sediments and things like that. And so we'll talk a little bit more about some of this going into Nicole's section, and also how to address some of these issues. But a few areas that are challenges to clean and safe water in North Carolina from pollution and chemicals and things like that are coal ash distribution and sorry, she's getting very excited. The PFAS, which we talked about a little bit last week, but I do not remember what PFAS stands for, but PFAS, they're the forever chemical. And we had the, was it the Gen X issue on the coast? And then hog lagoons. So hog lagoons can also cause some air issues when they're sprayed and aerosolized, but they also pose a lot of risk to, you know, if they're is flooding or runoff can also pollute a lot of surface water resources. So again, not to be a bummer, but to address some of these, some of the things we are able to do and some of the regulations that are in place are the Clean Water Act and the Safe Water Act. And so thinking about what clean water and safe water means, they might seem like they're the same thing, but they do have a little bit of nuance. And so really clean water means thinking about not polluting our water. So not throwing waste into water. Whereas safe water, specifically like the Safe Drinking Water Act, has a lot more to do with, regulating different toxins or solutes in water, and then also what is required to be added for treatment purposes and things like that. But both of these really can impact the quality of, sorry, my dog's getting really excited, but they can really impact the quality of water that we're interacting with, whether it's in recreational situations or what's coming out of our pipes at home. And so with that, I'm going to transition over to Nicole E., who's going to talk a little bit more, especially about safe water. So I will stop sharing my screen here.
Hey everyone. All right, we'll go ahead and get started right in here now so that you're not listening to people talk for too long. So the parts that I would like to talk about today is what does it mean to be caretakers of our water? And I think before you can understand how to take care of your water, you kind of have to know, like, what are the ways that you're actually impacting all the different sources of water that come in and out of your life. So there are a lot of different ways that humans impact the Earth's water. And they can sort of be broken down into categories. I'm sure this isn't an exhaustive list, but broadly, there are things that we add to our water. We can change where our water comes from and draw from different sources of water. We can change the way our water flows or stop it from flowing entirely. We can change how much water we use, and we have influence over what we take out of our water. So, and that's just to say that, like, water isn't just H2O. There's often a lot of other things in there besides molecules of water alone. Okay, so some things that we add. For one, fertilizer. I think Haley mentioned that agricultural use of water is a huge part of how humans use water. And when we spray water on the fields, when we water plants, that water will absorb some of the fertilizer that we also spray on those same plants. And that will stay with the water as it runs off to wherever it goes next, a river, a neighboring county, wherever that may be. We also use, when we add things to water, or when we use water to water plants or water livestock, like chickens, pigs, anything like that, that water goes through that animal and it comes out as waste. And then we also use water to sort of dilute that waste. So one of the things that's really common in North Carolina is like hog lagoons, and that is just a lot of hog excrement with water added to it. And so that water, because it takes up everything that it passes through, it sort of takes up a lot of that livestock and agricultural waste, and takes that to wherever it flows next. Another thing is chemical residue. So if you've ever been putting like transmission fluid into your car and some of it, you miss a little and some of it drips out onto the engine or onto the ground or wherever, the next time it rains, that chemical residue will be added to that rainwater or that storm water and taken and added to the larger water source, which is usually like a river or lake. Chemical residue can also be a part of landfill runoff, which is just landfills where we dump all of our garbage. They are not covered or sort of excluded from that rain area. So if it's raining over your house, it's likely raining over a landfill as well. And the same thing happens, is that water falls onto the landfill, it mixes with whatever chemical substance wastes are within that landfill, and then it continues on with those wastes now added to that water. Similar with road runoff, when they spray the roads with salt, the next time it rains or when it snows, when that snow melts, it's taking that salt with it, and along with whatever other oils and things come out of your car. Nutrients, so that's similar to fertilizer. There are a lot of different ways that humans add nutrients to the soil, to different types of materials that we bury underground that can degrade and become a part of the soil and then become part of the water system. And then metals. So a lot of times we use metals to transport our water. And so in that process, the metals are eventually worn down, and particles of those metals are added to water as they flow through things like pipes, which we'll talk more about later. And then I just wanted to add a little thought that I had earlier when I was thinking about all the things that we put into our water. I think that in most cases, the earth, I'm going to try to make a religious connection, but I'm not a religious person, so just bear with me. In most cases, the earth, similar to like some whatever deity is the focus of your religion, offers us something beautiful and pure, which is water. And then humans take it and we make mistakes with it. We soil it. Sometimes we abuse it, and we return it to the earth, beaten and broken, and the earth purifies it again. So that's just a sort of thought, like trying to add some religious stuff in there.
I think that's beautiful.
Try harder. Okay, thanks.
I might use that.
That we should sort of really try to appreciate this gift that the earth has given us, and take care of our water. Okay, so another little visualization here, where our water comes from. As you can see, if this was like a cup, that big 97% is a cup, that would be the oceans. A little ice cube in that cup would be all of the fresh water that is available on the surface of the earth and underneath the surface of the earth. And then if you follow those little droplets in the corner, you eventually get to a spot where it says surface water. And so that is the amount of water that is in all of our lakes, swamps, and rivers combined. And then you can sort of add groundwater to that as a source of water, for like the water that we use every day. But that is what, 30.4% of 3% of all of the water on the earth. So as you can see, the really the largest burden, the largest proportion of the burden is on the tiniest source of water on our planet. So humans, everything that we do, or most things that we do, require fresh water. So it's really just those little drips at the end that we're taxing when we do all of these things, like brush our teeth and water our gardens and make sure our hogs are watered as well. And everything that we do is focused on this really tiny source of water that we are sharing with many, many, many millions of other species as well. So if you just take a minute to think about all the species, all the land-dwelling species or freshwater species of the earth sharing that tiny amount of water, and then we have to think about how much of that is us, and whether that's fair.
And I think it's easy to kind of not realize it because water seems abundant, right? Like it seems like you turn on the tap, it's always there. drive down the road, you cross the river. You might, like in North Carolina, we've had a few drought years, right? In the last decade, more
Mhm.
consistently. And I think that's the only time people actually think about, oh, water might be not as available, but they still turn on their pipes, so it's still
Yep.
there. So they're like, it feels abundant. It feels like a lot. It feels like it'll always be there. Yeah, but it's
Yeah.
actually a small portion. Yeah.
Yeah. Another way that we affect our water is we've developed engineering techniques that allow us to change how our water flows. So things like dams, irrigating for agricultural purposes, dredging, just like digging up things, pumping in aquifers, pumping out the water that's stored underground naturally, and levees and seawalls. So we attempt, they don't work super well, but we do attempt to control how the ocean flows over land as well. And controlling those different water flows or changing the direction or reducing the flow can affect anything from a salmon's ability to spawn to the flooding or drought of an entire community or state. And here's another visualization of just how much water that we are using. I know Haley touched on this a little bit, so I'll just give you one more number. The US, that's just us, that's not the rest of the world also, uses 332 billion gallons of water every day. And for reference, that is about 6,640,000,000 bathtubs of water every day. So I'm sorry I don't have the pyramid math off the top of my head, but I do have bathtubs for you. And then there's things that we take from our water. So depending on how we use it and how we change the environment that it flows through, different nutrients and minerals can be used up, which changes the water's chemistry and its role in ecosystems. So if we're taking up a certain nutrient that a plant needs to grow, and then that water is allowed to move along to the ecosystem where that plant lives, it may or may not survive if everything that it needs from the water has already been taken out.
Can you also just add a part about talking about when there's too many nutrients in the water?
Yeah, that was, I
Yeah.
think I mentioned that earlier, but nutrient pollution is also another huge deal. So that's like, generally it happens when you add fertilizer to a crop, and then that fertilizer is washed into the nearest water source. Anytime it rains or you water the plants, that water continues on and can flow into rivers or lakes, where it can produce an algal bloom. So that's like that little green, if you ever been to like a river or lake and you see like green goopy stuff, or the water itself looks really green or cloudy, that's algae, and it can actually take up all the oxygen in a body of water and suffocate anything else that lives in that water. So like fish and crustaceans, anything else that lives in the water that's not a plant can suffocate and die if too many nutrients are added to the water. So and then this is just a reminder that we're not the only ones who use water. Wetlands use water, and wetlands protect us from hurricanes. They can purify water. They're often called the kidneys of the landscape. They promote biodiversity and they support food resources. So those are all really important things that water is being used for by someone who's not us. Plants use water. Trees that help purify our air and stabilize our ground. Their roots actually sort of keep a lot of mountainsides in place. So if you lose those trees, you're going to be seeing some mud and rock slides. The plants we use for medicine, for shelter, and for food use water. Plants that support all other life. If you want, beef for dinner, that beef has to eat something, and that's usually plants. And they use water. Animals, the ones that feed us, the ones that love us, and the ones that adorn us, use water. Those that maintain the world around us and contribute to the functioning of ecosystems use water. Those that manage one another, like fox and the hare type situation, use water. Those that pollinate plants use water, and those that spread the seeds of plants use water. And additionally, those that we learn from. We've learned a lot from animal species over the course of the existence of ecology. And so those organisms that we learn from use water. And then lastly, though it's not alive, chemical processes that everything that lives rely on use water, like photosynthesis, decomposition, osmosis, which is like dilution, acid neutralization, and soil formation all use water. And that water needs to be in a certain state for it to be available for those processes. Okay, so what does it, now that we know a little bit more about how we use water and who else uses water, what does it mean to be caretakers of our water? And there are several groups that do a lot of volunteer efforts to sort of clean up riversides and fight for the safe and healthy waterways that we need for our ecosystems to function alongside humanity and along with humanity collaboratively. And the River Keepers are one of those organizations that's really cool. I have a video, I'm not sure if we're gonna have time for it, but they aim to bring together communities to identify pollution sources, enforce environmental laws, and advocate for stronger environmental laws while engaging in restoration and education to empower the public. But there are a lot of different ways that you can be involved in taking care of your water, and going outside to meet the water where it is just one of those ways. You can also change the ways in which water comes to you through thoughtful use, which there's a lot of simple things you can do at home, you know, like take shorter showers, don't leave the water running while you brush your teeth, simple things like that. And then there's also ways that like congregations or groups of people can be involved, especially if your operations are based inside of a building. So like you can serve tap water at meetings. You can just really take the time to understand your water flow. You know, are things running while nobody's in the building? Is there a more efficient water fountain that you could be using funds to get? You can take another look at your landscaping, especially for older buildings. They were built before we knew a lot about how landscaping changes the use of water around human infrastructure. And so planting different plants or maybe grading a hill a certain way can change a lot of how water interacts with your property. And then you can also encourage water conservation at home. So encouraging people that you're close to take those simple steps at home, like shorter showers, even things like, well, I guess it's not saving water, that's saving energy. But there's a lot of different little things, and you know, you can find those just about anywhere to reduce how much water you use at home. And then you can also participate in citizen science, which is a little bit more of what we'll be talking about today, to help monitor changes in water quality characteristics in general, and ecosystem effects for your local water sources. Okay, so this is where the project that hopefully you guys will be involved in comes in, and it's called Crowd the Tap. And our goals are to increase safe drinking water in the US, identify areas for infrastructure replacement, develop a reliable and inexpensive water testing protocol, and increase awareness of water quality issues through intergenerational learning. There's a couple of different types of pipe materials that are usually used in houses and underground for, you know, townhomes, apartments. It can be anywhere you live, you have water pipes. And there's a couple of materials that they can be made out of. One is steel, one is copper, one is plastic or PVC, And then one is lead. And if you have lead pipes, it can be a very serious health concern for the reasons that you can see here. In adults, it causes some memory loss, lack of concentration. It can cause digestive issues. It can damage your nervous system, and several other things. In general, you don't want lead in your water. And specifically for children, it can cause like mental degradation or lack of brain development. That can be really detrimental and is a permanent effect of exposure to lead. So if you have lead pipes, you really want to figure that out and find out what you can do to replace or resolve them quickly. And these two graphics are just a representation of what happens when water is properly treated and is flowing through lead pipes, and what happens when water is not treated and flows through lead pipes. And so you can see if water is treated properly, there's chemicals within the water that will coat the pipe so that the water doesn't actually make contact with that lead. And it's allowed to flow through the pipe without collecting any lead particles. But when the pipes aren't treated properly, lead is making contact with your water, and lead particles can become a part of your water. They're not visible though, so you won't be able to like see them or avoid them with your eyes. And so our project is based on coming to people and offering them materials to find out what their pipes are made of. We're also trying to create a national inventory of where lead pipes are, because though they were outlawed in like 1986, there's no all-inclusive record of where these lead pipes were taken out, if they were replaced, where they were ever put in. And it's hard because they're underground. So, you know, depending on how structures have moved and how people have developed, like you'd have to dig up underneath somebody's house or underneath a road to figure that out. So what we do is we bring people materials so that they can figure that out just by collecting water from their sink, rather than, you know, spending the money and all the time and the hassle to dig up the ground to see if they have lead pipes. I think most of the people who would be watching this would be ambassadors to a larger group, right? So I had a couple of things to keep in mind if you're doing this project and you're sort of leading it with another group of participants. And so one of those things is just open communication. Please keep in mind that we will have people from different backgrounds participating. And it's likely that people will have different kinds of questions and different concerns and different needs in terms of communication about a project like this. So watch your email, and you can also CC Crowd the Tap, or just include us as a recipient of the emails. Crowd the Tap at ncsu.edu. I'll put that somewhere. CC us, and then we can answer questions as well. And then there's a lot of resources that we offer. There's a webpage with several videos, training materials to tell you more about what citizen science is and why it's important, and how to sort of go about it in a way that is beneficial. There's a lot more resources on our website for people who want to be involved in our project. And then Haley and Nicole J and I and Karen will be available to assist you with any sort of technical queries about, you know, how to enter data the right way, or, you know, something's not working on the website, what do I need to do? And then there's also, if you're doing this with a larger group, there's a couple of things logistically that you'll need to be able to handle, like how many or which materials your group needs. When you plan to host meetings, maybe you want to do like a live demonstration of how to use the little chemistry strip. We're not going to get into a demonstration today because I think we're not sure who all is signed up. And we're running a little low on time. So, and then you just also need to be aware of how and when different people will participate so that you can make sure that it's accessible to whoever wants to participate. Okay. So I was trying to go a little fast there towards the end. But yeah, that's what I have for today.
Thank you, Nicole. Thank you, Haley. Stephen had said he had another appointment at 12, so he had to leave early, but that was fantastic. That's a lot of information. And all this information is going to be made available and put together for faith communities who are going to participate in the citizen science pilot. So that'll be great. I have one question. And so there's a section where you're talking about take another look at your landscaping. So a lot of congregations and faith communities, they have a lot of land. We don't always think about it, not just like the congregations that have big parking lots, but faith communities that have a lot of land that's not necessarily being used, or it is, or sometimes acres, many of them. So what would a congregation want to think about if they have a lot of land and they're thinking about the water in their community where they're located? Yeah.
There's a couple of different areas that I can think of. I'm not an environmental engineer, but I can give you a couple of different things. So one thing is like the next time it rains, you'd want to go out to your parking lot and try to trace where, you can kind of see where the water is flowing, where it collects in the parking lot and sort of where it runs off there. I would trace the point where your parking lot sort of, that water is discharged into the natural ground environment. And you can put certain species there are good at absorbing and sort of reacting within themselves with toxins that can come off of like a parking lot type situation. So there would have to be a little research done, maybe hire someone who is specifically trained in how to deal with that type of environmental pollution. But I think it's really likely that you could plant certain species at that runoff point that would help sort of contain or absorb and dissipate any sort of chemical runoff that was coming off the parking lot. Another way to sort of think about landscaping and water is to think about what kinds of plants you have ornamentally. And some plants will require a lot more water to maintain than others. So if you have something that's like a really, really needy water species, you could maybe move that to a place that naturally gets more water. Like if it's underneath the side of a building, so when it rains, there's a lot of water just dripping on it, just to sort of use up the water where it's abundant. And then in that space where maybe if it's in like a landscaped area that's not near a building where there wouldn't naturally be as much water flow, you can replace species that need water there with species that are more drought tolerant, so that you're not constantly watering those needy water species in areas where there's not a whole lot of naturally occurring water. So it's just really thinking about what species water needs are and putting them around your property in ways that require the least amount of additional water, so that you're not out there spraying for hours with the hose plants that could just be next to the building and getting a ton of rainwater runoff from the roof.
My church did a project a few years ago where we found the native species to our area where our church is, and we added them back in.
Mhm.
And that was just a really cool project to A, learn about what things were native to our area, but B, they're used to our climate and our temperature. And so we didn't have to go out and water them as much.
Yeah.
So if other churches want to learn more about that, they can contact me. But I love the idea of moving plants underneath a building. I should do that at my own house. That's brilliant.
Yeah, and then
Um,
there's a lot of different. Oh, go ahead, Haley. Did you have
Oh,
some?
no, that's okay. Well, I was gonna say, yeah, I could do like a 30 to 45-second plug for like other water resources, but I also want to make sure Lee has a chance to ask any questions if he has any. But yeah, and Nicole, Jay, if you were thinking also in the context of like more wooded areas and like stream resources and stuff like that, if we're talking like larger plots of land, that might even be something we could work on future stages of the pilot, do more like a water quality focus on other things. But yeah, just some really quick things, thinking about natural waterways tend to be really good habitat for a lot of animals. So there are some things you can do as far as like looking at, habitat, maybe putting out habitat boxes, things like that. And then because water does transport a lot of things, invasive species can tend to be common around waterways. So also, investigating invasive species, maybe doing some removals, things like that. And then there are just tons of other things you can do with like water quality and pollution and stuff like that. So yeah, if there are groups that are interested in that, maybe we could try something like that again in the future and do another water related project as well at some point.
Yeah. Any other questions from anybody?
Okay, last one. My last one anyways. So since you've been working with Crowd the Tap, is there any data that you can share with us just off the top of your head about lead pipes in North Carolina, like prevalence or not,
Let's see.
or how much testing of
Yeah,
people's water in different communities?
I can share. Okay, so I think we've got. Oh, it'll take me a second to find it. So far, I can't give you North Carolina specific because I'd have to filter that out of the data set, unfortunately. But we have gotten data from 2,284 households so far in all 5 regions of the US. And a lot of those are from North Carolina just because it's an NC State based project. So a lot of our connections are sort of in this area. And I don't think we found, I can tell you we haven't found lead pipes in Raleigh because I know two of us at least are in Raleigh. I think the most concerning areas that we have would be like Eastern North Carolina. If that's like as specific as I can be without a spreadsheet in front of me. Okay, and so that's all I have today. I don't know, Nicole, do you have anything else? Other Nicole?
All right, sorry. I just want to say thank y'all. This is going to be great. We're going to put together all this information about water and hopefully help to definitely generate some engagement about water and about participating in citizen science projects. For the pilot, we are hoping to engage 15 to 20 faith communities to participate in some citizen science projects. We've selected 3 in particular, and one of them is Crowd the Tap, hence we're doing the science of water. We wanted to talk more about water in the rituals we use, water in our ordinary everyday life, but also what happens when that water is not clean or that water is not safe. And we're hoping that this is a chance for faith communities to participate in a way that helps them become more present to the environment around them and their place in the environment. So we're going to be sending out information. We are continuing to take signups for the pilot. And let me locate the sign up link. That will take me just a second. So we have an interest survey that somebody from a congregation can complete. And we are taking names from that, and we're going to be following up with them to participate in the Environment, Faith, and Health pilot initiative. And what we're hoping is that they'll participate. They can choose whichever citizen science project they do want to participate in. Here's the sign up link. And we will be offering webinars around different aspects of faith, health, and the environment. So including like this water one, we had one on sacred conversations, water and rituals. And then this is the science of water. So there'll always be kind of a theological framework, and then one from a scientific perspective. And that initiative will also have a $500 mini grant that a faith community will be able to use towards some sort of environment, health, and faith project for their congregation. We're going to be developing kind of a library to lend out to faith communities who want to do small group studies. We're hoping to develop some worship tools, even some maybe one-page flyers about things they can do in their community around kind of the environment, health, and faith. And what I'm really excited about is that participants will get to have their water tested for lead. And then there will be follow-up from that. And we'll also be supporting, have support from undergraduate and graduate students from North Carolina State University and Shaw University. So I'm really looking forward to those things. And I think we're gonna slowly be rolling out as we continue to add resources to our website, which I'm also going to drop in the chat. My computer is going very slow. Something about I have low system resources. I don't know. Just a second here. So we do have a citizen science page on the Partners in Health and Wholeness website. And we invite you to share that far and wide. They're not really. I'm not sure if people can see things in the chat or not. Okay, all right. So that's all the information we have about that.
Not in the recording, but I'll put
Okay.
it with the description so everybody has access to it.
Yes, thank you very much, Elizabeth. So that's all we have today.